Hey everyone, thanks for coming to my presentation about application security maturity model. Most of this presentation is specifically geared towards software companies, but it's also about how we can approach the vendors that we deal with and ask them about their application security maturity model and ask them what pieces they do and do not have implemented. So to start off, my name's Kenton McDaniel. I love cracking passwords and I love Privesk. Those are my two favorite things about InfoSec. I like lots of other stuff too, but those two things are my favorite. So talking a little bit about application security, and by the way, it's super bright up here and super dark out there. If you have a question and I don't see you raise your hand, just yell. But feel free to ask questions during, and just interrupt me. You can heckle if you want to as well. So application security is the idea that we, as software vendors, should secure our applications to protect the company and to protect our customers. And the methodology by which we develop software is the software development lifecycle, or the SDLC. So SDLC is a term I'm going to be using. If you've ever heard of it, it's just the idea that my developers write some code, it goes through a testing process, whether that's automated or manual, and it gets deployed. So there's this software development lifecycle that all code should go through before it reaches our customers' hands. Where does security fit inside of that SDLC? As your org matures its SDLC, security should be adopted earlier and earlier into the life cycle to the point where it's embedded in every single stage and thought of in every single stage. But it is a process. No company goes from zero to best practice overnight. You don't even get there within years. It's a long process to implement your application security maturity. So you need significant investment in people and tools. No one platform, no one anything will solve this problem for you. You have to invest heavily in the right people and the right tools, which requires a lot of executive buy-in as well. So if your executives aren't bought into application security, you won't be successful. If your team is not bought into application security, you won't be successful. So these are rough outlines in my head of what the phases are. Any of these disciplines can be adopted at any time. It doesn't have to go beginning, maturing, platform, and innovative. But where I see it is when you're starting out, you focus on certain things. And when you're starting to get more mature, you focus on different things. But that doesn't mean that you can't adopt them all at once. I don't recommend it unless you really feel like you understand the space, though. You need to be flexible, too, because as soon as you start introducing application security into your SDLC, your developers will either be super excited and want to help, or hate it completely and not want to buy in, or somewhere in between. So you have to gauge your process. Small incremental steps of building AppSec is the way to do it. So, like I said, you have to have funding and executive commitment. I said that twice because it's incredibly important. If you don't have executive commitment, you won't be successful, because at times your application security process will slow your development and could stop development completely. So if you don't have that commitment from your executive level leadership, when you stop development to address application security issues, they will be upset. But if you have that buy-in, there will be an understanding there and a commitment to application security excellence. And by the way, I'm going to talk about multiple disciplines. No one person should accept all of these disciplines as their role. If they do, they are not able to be excellent in those roles, right? We're spreading people way too thin. If we say, I've got one AppSec person, he does all of it, that's not good for our AppSec people. We need to spread out the role and hire more people. And I know hiring's tough, right? It's all about time, money, and resources. But in order to be truly excellent, you have to have the right people. So beginning discipline. When you're beginning, you recognize, hey, we should do something about application security. The code that we write is consumed by our customers. We should do something to secure that code. Even spreading awareness of that is a step, right? Even just saying, hey, we should do something is a step. It puts it in your developers' minds and their leadership minds that we should be doing something about our application security. The tools, tactics, and procedures for the beginning discipline are static source code analysis, so SAST. By raise of hands, has anyone ever dealt with a SAST tool? I'm shielding my eyes so I can see. Okay, cool, awesome. So we have some awareness of what SAST is, right? And then we've got manual application testing and secure code reviews. I would say those are your foundational pieces that help you build your AppSec program. So let's talk a little bit about SAST. So for anyone who's not familiar, the idea behind SAST is my code gets scanned on regular intervals. Hopefully every single time someone commits a piece of code, or pre-commit even, that code gets scanned for known vulnerability patterns and types. That's all it is. So it's not a silver bullet. There's some really good SAST vendors out there, and there's some that tell you all you have to do is implement our SAST tool, and you will remediate all vulnerabilities before they hit production. They're lying to you. They can't do that, right? I mean, there's logic bugs, there's configuration bugs. They don't understand the space completely. So SAST is just one tool in your arsenal to help your code be secure by checking for patterns. And it gives you baselines, though. If you're adopting legacy code bases into your SAST platform, you get baselines of what do we look like now so that we can set goals, achievable goals, for what the future of the code base looks like. Because it's not very often that we just get to go full greenfield, right? We hardly ever get to be like, let's just build a complete code base from scratch that never had any other legacy code. We're bringing legacy solutions in and we're implementing controls within those legacy solutions. There's a lot of paid options for SAST. There's a ton of free options as well. So you have to mix your budget, your hosting model, your licensing model, and the features that you want. Talk a little bit about the budget part, that's just the dollars and cents. The hosting model, though, is it cloud hosted? Is that okay to take your source off-prem and take it up to the cloud? Is that okay? For some orgs, nope, not okay. So you gotta go, okay, I gotta be on-prem completely. So you have to understand the risk profile that your company is willing to accept with their source code. And it may change. And so that opens up some doors for you for vendors. The licensing model as well. Is it licensed per developer? Is it licensed for the entire company? Is it licensed by the number of times you run the tool? There's all kinds of licensing models that you can get into, and if you don't pay attention, your spend will skyrocket, right? Because you're thinking, oh, cool, we're licensed for everything. Well, yeah, you may be licensed up to a threshold. You turn it on for all your legacy products, all of a sudden your spend just eclipsed what you were supposed to be able to spend on it. And then the features. Does it support all the languages that you want to scan? Does it support the platforms that you want to scan? Not all of these are equal, and some of them are super awesome at the specific thing they do, but they're not great at the others. So you have to balance what is most impactful for your organization. And also, all tools will have false positives. Any salesperson that tells you their tool has 0 false positives is lying to you because they don't understand the nature of a false positive, right? So you have to have someone who can deal with that. You have to have someone who can triage the false positives, turn them into workable tickets if they are true positives, and look at the false positive and say, you know what, yeah, that looks like that's SQL injection, but it's really not, and here's why. Because these SAST tools are pretty good at finding what they think are vulnerable implementation patterns, but they're not perfect because no piece of software is. And then it takes a lot of discipline and studying to be the person who can triage those results, look at them and say, yeah, that's a true positive, or yeah, that's a false positive. Because it's not just a developer thing. You have to be able to look beyond the code that's written and say, yes, this is vulnerable and here's why. You know, ideally, it's because I've exploited it in the past in this type of implementation, so I know that it's vulnerable. Manually testing. So I talked a little bit about SAST. Now we'll talk about manual application security testing. You strive for maximum coverage by testing with a proven methodology. Whether that methodology is homegrown, if you make your own methodology, but you prove it over a time frame, fantastic. But developing a proven methodology takes time. OWASP Top 10 is a great methodology to go by. There's tons of resources out there about application security testing methodologies. I recommend you build your own by taking the best pieces of other methodologies and frameworks out there. It's like compliance frameworks. If you implement one single compliance framework, you're going to be missing pieces of what's important to your organization. So your AppSec team should strive to implement a testing methodology that works for them. And manual testing is still huge. Manual testing is a very crucial part of your application security platform. You have to have people there trying to exploit those vulnerabilities because, like I said, you've got the source code, but then you've got how it's deployed. When the source code's fine, but I deploy it in an environment that creates a new vulnerability, can I prove it by exploiting it, right? It's either POC or get out. That's the thing, right? Can I exploit it? Yes. If I can, it's a ticket. If I can't, it's not a ticket. Okay, so secure code review. The idea behind implementing a security focus into your code review process with your developers so that they recognize some of these things. And this takes time, but it's a great thing. You can start to create pockets of security excellence within your development organizations. I'll talk a little bit about security champions. So maturing discipline. So you'll see the maturing discipline adds one new thing, but we're just expanding our coverage and our focus of two of the prior things, right? So SAST, manual security testing, and now we're adding dynamic application security testing. So the difference here is, so I'll go back real quick. SAST, we're just expanding our usage of it, right? Where when we're beginning, we may have just targeted one critical code base, but now we're trying to roll it out to everything that we own to make sure that we've got full coverage everywhere that matters to us. And we're expanding out our manual security testing. So we're trying to get better at developing those. And then dynamic is using tools to perform dynamic testing against a running application. So that's the difference. Static is, I've got some source, I'm analyzing it. Dynamic is, hey, something's running here. I'm going to start running something against it. Has anyone ever used Burp Suite in the room? Love those show of hands. Love Burp Suite so much. Has anyone ever used Burp Suite Enterprise? I think it's a fantastic tool, and that's kind of the idea behind Burp Suite Enterprise, was to be able to have something persistently running against new workloads that you can point at it with a set of tests and have it execute those tests and give you back results. Now that sounds static. It is static. The dynamic part is the application is actually running and providing feedback. So the test itself is rarely dynamic, but the application is running. So that's the important distinction. A lot of people are like, oh, so dynamic testing means it learns and it's AI and ML driven and it learns and adapts the payloads. I've never seen a tool do that successfully. If you have, please tell me because I would love to see it. It's just that it's running and you're getting real feedback from the running application. So performing your dynamic testing as close to post-deployment as possible will give you your best visibility. So pipeline-driven, right? We all want our development practices to be pipeline-driven. Putting the dynamic right post-deployment in your pipeline gives you the absolute best availability to find those exploits and those vulnerabilities post-deployment. So now I want to talk about platform security. So we talked about beginning, maturing. Now we're talking about platform because we're all hosting our applications somewhere or they're on-prem. If you sell solely on-prem stuff, then our platform security is what we preach to our customers, right? But if we're hosting SaaS, platform security is a shared responsibility between us and the SaaS hosting vendor, right? So if we host something in Azure, is it secure? No, right? That just because you host something on a platform that takes good security practices doesn't mean your application is secure. So talking about looking beyond the code you're deploying into the way you're deploying it on the platform. I talked about how it's a shared responsibility model. Posture management applications are great. I cannot remember the name of the NCC tool because I'm on the stage and it flew my mind. But there's a tool written by NCC Group that will do posture scans for you against your cloud tenant for free. And I can't, my friends are going to be laughing at me when they watch this, but I can't remember the name of the tool. Fantastic tool. I think it's Scout. So look for NCC Group Scout. And it'll perform this posture analysis for you free. And there's tons of paid options, right? But the whole idea is it looks at how you've deployed in this cloud tenant, tells you what your issues are and how you can remediate. Ideally, if you're deployed hybrid cloud or multi-cloud, it would aggregate all of this data for you into a single place so that you have it for all of your deployments. So innovation. This is where we talk about finding ways to build our application security platform that involve more commitment. So before I talked about things that, mostly your InfoSec team can do a lot of those. You need some involvement from your dev organization. Now we talk about really deep involvement from your dev organization and really deep involvement from your organization as a whole. You can't reach innovation stages without really, really deep commitment. So security champions programs, CTFs, secure coding training programs, and bug bounty. So bug bounty is the absolute last one because I believe you should never implement a bug bounty program until you have got the rest of your AppSec program buttoned down to where you feel it performs highly. Bug bounty should not be an entry-level requirement of an AppSec program, in my opinion. So security champions. The idea behind a security champion is you put people on development teams that are responsible for the security of the product they're creating. Now, what that responsibility means is they get access to, maybe if you're using a SAST tool, which I recommend you do, they get access to the results from the SAST tool. They get access to the results from the dynamic tools. They're the ones who can champion these initiatives on the development teams, but they still report through development. So you've got your application security people, and they collaborate with your security champions. You want to push the ownership of security into everybody else's hands, not because you're abdicating ownership, right? You want to push it into their hands so that there's a shared responsibility there, because then you can truly get some great results if everyone shares that responsibility. It's not an easy thing to do. You have to get deep commitment from your dev teams and from your orgs to be okay with losing some time each of your sprints, iterations, to security. But it will pay dividends for you. CTF, has anyone ever participated in a CTF? Great. I would guess most people have. So the idea is your CTF gives your developers exposure to a vulnerable application that's running, and you help them through the process, right? Like I created a CTF, put some videos up on YouTube about it, about how to compromise the running services and applications, walk people through it, help them gain the understanding. So when we think CTF, sometimes, InfoSec people think, oh, CTF is a black box. I just look at it, I don't know what's in there, and I have to exploit it just by enumeration. That's one approach to take with your devs. I would recommend an interactive approach where you guide them through the process, help them get the flags, help them be successful. Put out videos showing them exactly how to do it, because as soon as they exploit their first vulnerability, that's where you find your security champions, right? Because some of them will be like, man, that was awesome. I got a shell on that host through SQL injection. Tell me more. Some of them will be like, that was boring. I don't want to know about it. But you can identify your security champions by giving them the opportunity to exploit things. Maybe none of them have ever had a shell before. That dopamine hit when you get your first reverse shell. Get them hooked on it. It's a great way to identify your security champions. And then secure coding training. So secure coding training teaches your developers how to code in a secure manner. So there's lots of vendors out there that'll sell these products to you. There's lots of free resources online as well. This is where you're challenging your developers, every single one of them, to take security as a priority while they're writing their code. So that they're looking at the code they're writing for security vulnerabilities, and they're being trained about recent security vulnerabilities as well. Yes?
Do you have any experience in negotiating sprint cycles to that kind of training, or other ways in which you're incentivizing that training with support from management in a way that makes it consistent and effective?
Fantastic question. The question was, do I have any experience in negotiating time within sprints to dedicate towards security functions? And the answer is, the best thing that I've found is incentivization programs that you can build for simple things like swag or things like that. And then really emphasizing it at the executive level down, because then when you go to your product people and you go to your dev people, you're not the one asking for it, right? InfoSec's not asking for it. It's already been negotiated at the executive level. And it's now just, how do we fit that into our sprint? I had a wonderful conversation with a group of devs about their time allocation. And it was great because they were already said security is a time allocation. I didn't even have to bring it up. But you have to get that executive support, because an InfoSec group alone can't push that through. The dev teams have to serve a lot of different purposes. InfoSec is just one of those. And so you have to be mindful of that, number one, and number two, you have to negotiate at the right level. And if the executives aren't willing to negotiate with you, force them to, right? So, and that can be a tough conversation to have, but you force that negotiation. You say, look, listen, we've got these tickets, we've got all these things. We need to take this seriously. We need to have this negotiation. And then at that point, if there's no negotiation to be had, at least we've done our part to make sure that we've brought this up. So sometimes we have to be willing to accept that it's not going to happen. And that's the part that sucks, right? You make a ticket and the ticket doesn't move and you're like, hey, I really need this movement on this ticket. And that's the part where you have to walk away and it really sucks. But I feel like managing that expectation at the executive level and letting the dev leads communicate to the devs the priority makes all the difference. Because if it's just InfoSec communicating the priority, they're less likely to listen in my experience, but when dev management communicates it, completely different ballgame. So that's my recommendation. And that was a super long-winded answer, I'm sorry. So now for those who don't run dev teams, right? Or if you're consuming software as a service, here are some questions to ask your vendors about their AppSec program. Do they do security code scans, so static scans in their SDLC? Do they have dynamic in their SDLC, and do they have dedicated security engineers? Those 3 questions will tell us a lot about an organization. If the answer to all 3 of those is yes, I feel really comfortable partnering with that organization because I know that they at least are trying. So, I mean, you could ask like a 100-page questionnaire and get every single part of it, but if we get these 3 answers, we know that they're trying and they take it seriously. That tells me that's someone I want to partner with. If you're doing these things, even if you're doing 2 of these 3, I want to partner with you because when I talk to you about security, I know that you care. And that's the huge difference maker. And then the last thing is bug bounty program. So a bug bounty program is super expensive to maintain and requires specialized training. Has anyone ever done triage in a bug bounty program? So I feel you, right? I've done triage in a bug bounty program, and it's different. It's different than triaging anything else. You have to maintain a relationship with your researchers that's profitable for them and for you. And so you have to triage on certain SLAs, right? You have to keep your SLAs for triage. You have to have someone who knows how to triage because it's a completely different ballgame. You're getting vulnerability reports from researchers who may or may not give you all the data that you need. You know, sometimes they'll just be like, hey, I got cross-site scripting on this endpoint. And you're like, cool, there's like 150 routes on that endpoint. You know, so you have to maintain and cultivate that relationship with your researchers. They are your most valuable resource. Then you have to know what payout is. You have to pay attention to payouts because if your program's not attractive enough to researchers, they're going to move on to something more attractive. So if I'm paying out $5 for cross-site scripting and $10 for command injection, I'm going to get 0 reports, right? Unless someone can find it with an automated scanner, I'm getting nothing. I have to make my payouts attractive. I have to make my disclosure meet what the company wants, right? So bug bounty is, in my opinion, the last thing you should try to implement unless you've got everything else in order. Otherwise, it's a bad experience for you, the company, and it can be a bad experience for your researchers. And if it's a bad experience for your researchers, then researchers talk, right? So I'm a vulnerability researcher myself. I'm on all the major platforms. We talk to each other. You know, I had a bad experience with this vendor. I'm probably not going to go back to them again. And then my friends will be like, oh, you had a bad experience here? I'm not going to touch them. So you have to maintain and cultivate that relationship. Does anyone have any questions? That's all I've got. Does anyone have any questions? No. Thank you so much for your time, guys. I really appreciate it.